Good morning, ladies and gentlemen, Lotus Carlton, Lotus Omega owners, friends, ex-Lotus staff, and current Lotus staff. My name is Alastair Florence, and I will be hosting today along with the rest of the team from Lotus. And it is a hugely warm welcome to you all for coming from all over the world to see us. It is actually very humbling that this little village, tiny little village in the middle of South Norfolk on the east of England, has become probably the most significant centre of sports car engineering in the world. That's my words, and I hope you all agree. And as I say, it's amazing for us to see all you guys have come such a long way from the mainland of Europe and from the UK to come and see us today. So that is humbling. So I'd like to also just do a couple of words of thanks to a few people here. First of all, my colleague Diane Winchester, who has been an absolute rock in in organising this event. So I'd like you just to give a quick thank you to her. I would also like to thank Mike Kimberley, MJK, as he's known as, former Chief Executive of Lotus, who has, as a former member of staff, although we still regard him as being a key member of current staff, who absolutely pulled it together as far as our colleagues, or former colleagues, joining us today. Please. I'd also like to thank Andy Betts, or Bibbs, and Darren Woodhead, who will be around all day taking pictures. So a big thank you to them. And this event would not have been possible and would not have happened without this gentleman here, Paul Rees.
Thank you, Alastair. Yeah, just a couple of things, guys. I'd like to thank people as well, same as Alastair's done, the same people. They've been amazing. It was a rocky road to start off with me and Julian, but then Mike come on board and Alastair and Diane, and they paved the way. So thank you, guys. Julian's been a great help as well. So where is Julian? Give him a round of applause, because he has been in the background there he is over there. Flying emails everywhere, and yeah, he's been a rock. So thank you for that, mate. Just what Alastair said, obey the rules and the track time and that sort of stuff. We aim to have 3 pictures taken by drones, hopefully. One, when we do the track times and we go to the last lap, we'll go to where they're going to do the photos. Sit in the cars, let the drone take the pictures, then get out the cars, let the drones take the pictures, get back in your cars, and we want the ex-workers with the cars as well to take pictures again. Okay, we want to try and recapture the image that was done back in the day of the Lotus Carltons with all these workers that we all appreciate. Without you guys, these cars wouldn't be on the road. So yeah, thank you very much. Just one other thing as well. My darling partner, Trish, wherever she is, somewhere. She's hiding. Just want to say thank you to her, because she has been by my side with all the stress and everything. So thank you, babe. Appreciate it. And if you haven't done the track indemnity, there are tablets around, I believe, that you can do the online indemnity and get that sorted out. So please do that before you go on track. We need that done before you get on there. Okay, so yeah. And one last thing, thank you everybody for coming. Absolutely amazing. Those guys that come far and wide, Norway, Belgium, Poland, guys, you're amazing. Thank you very much. Over to you.
The Q&A session. Now, the first Q&A session is, we've termed it a commercial, design, and politics. There's one person we couldn't get along today because we couldn't find him, and that is Bob Murray. Now, I'm sure you'll hear a little bit more about Bob Murray a little bit later on. If not, you're very welcome to Google him whilst you're listening in. But first of all, I would like to welcome to the stage our head of purchasing from the time, Christine Garrett. So, and the designer of the Lotus Carlton, Julian Thompson. The Chief Executive of Lotus at the time, Mike Kimberley. And Project Director of the Lotus Carlton project, the whole project, Simon Wood. So, where's the other mic? Ian. Ah, lovely. Brilliant. Thank you. Great. Super. Mike, I'll give you that one first. So we're going to just do a few questions, and these questions are very open questions. So hopefully you guys will learn something which you don't know or you've never known about the Carlton. So first of all, we're going to start with Mike. Mike, as Chief Executive back in the day, you led the whole project at the whole business level. Why and how did it come about?
Well, fundamentally, Lotus, as all you guys would know, has a history of joint ventures, and the Lotus Cortina was the start of it with Colin Chapman, which was a great success. Then we did the Lotus Sunbeam, which won a RAC Rally Championship. So it was based upon a win-win with a client company that was good for them and good for us. Obviously, it was very good business. Colin, sorry, not high enough, okay. Got to bear in mind, now GM had taken us over in January '86, and at that time, that was quite a change to a little company like Lotus, as you can all imagine. I'd been working with them on Lotus engineering projects since the early 80s. It was something that we'd done, active suspensions, new engines, and so on and so forth. But when they actually took us over, Jack Smith took over as president of GM Europe, and I saw this as an opportunity, obviously, of doing some sort of joint venture with them to turn one of their Opels, or Vauxhalls, into what we would all call a supercar. That was in 1987, the start of 1987. Julian, sitting next to me here, carried out some sketches. And first time I met Jack over in Zurich, bear in mind GM Europe was separate from Opel in those days. It was separated because Opel was the big, large manufacturing and engineering company, and GM Europe was controlling them like it was controlling us. So I met Jack Smith, the president of GM Europe, who actually was in charge of Opel as well as Lotus, and pitched the idea of a supercar, which would, in those days, was first of all the Lotus Senator. You probably read the book, I'm sure, that Ian Adcock wrote. You've seen the information in it, I'm sure. Julian did the sketches, and some of the data, some of the information came out of our engineering department as to the performance. At that time, I have to be honest and say that it didn't exactly get a positive reaction from our friends at TDC at Opel. That's putting it rather mildly. Then Jack Smith went back off to Detroit. He was promoted, and Bob Eaton, a very old friend of mine, a family friend, came in and became the president of GM Europe in Zurich. Well, we got together straight away, and we decided that this sort of project had to go ahead. Again, Julian came up with proposals. Peter Stevens was running the design studio here at the time. Julian was looking after this project. We called an executive meeting over in Zurich, at which our friends from TDC Opel were there. I can't say that it was a very positive meeting. Our friends in Opel were at that time bringing out, it appeared at the meeting, a new Omega And that new Omega had a lot of interesting specifications technically, like the five-link rear suspension, like the new engines, new base engine, which we obviously thought, well, that's a much more preferable car than the Senator. So we then reverted back and proposed a new specification, including the Omega, or in actual fact, the Carlton, as it was at that time. At the time, we had this very, very tough meeting. It was called an International Strategy Board meeting. It was quite a difficult one, where I think Bob Eaton, as the chairman, had to break a few times to have coffee and sandwiches just to let the temperature reduce. It got quite heated. It was difficult, but nevertheless, we were given the green light to go ahead. One of the key things that I insisted on at the time, was it had to be the best in class. It had to be the best in class. We were competing with, I wanted, and so did Bobby, we wanted to compete with the best of the BMWs and Mercedes. We wanted to outperform them. Fundamentally, that was it. No ifs and buts. Well, our friends at Opel were not quite sold on the idea, but nevertheless, we started to proceed. Wayne Cherry, people like Wayne Cherry, the designer, was very positive towards it. And we had a lot of positives, but from Opel itself, it became quite a challenge, which Simon, sitting next to me here, as the project director, had to cope with as we went through the program. So it was kick-started. Thank you. It was kick-started, and in actual fact, if I can just check my notes, because it was a long while ago now, 35 years. Thank you.
That was.
Yeah. The working relationship all the way through the project was of the level where I would say that Simon and the whole team here, manufacturing, engineering, development, design, especially the durability, and then the prove out, the certification. Every time we came up to a point where the development car needed to be agreed by both parties, we seemed to hit some of those invisible sort of barriers. And it turned out in the end, what I had to do with Bob Eaton, we just said, okay, we'll do it, instead of our friends at Russellheim having to do it. In the end, that's why, as you guys all know, that's why we finished up actually building the car here at Lotus. That's why you really have the best supercar in the world. And then, of course, later on, we hit another barrier, which was unfortunately a guy called Bob Murray, the editor of Autocar and Motor, who must have had a brainstorm. It went absolutely mad. Instead of being a car guy, he decided that a car of this nature shouldn't do above 155 mile an hour.
We'll come to that later.
All right, thank you.
Absolutely fascinating. So, Julian, you were obviously involved right at the start. How did you actually get involved?
Well, Mike, was always coming down to design and always looking for the successor for the Lotus Cortina. It was always a thing, wasn't it? And we always used to do all these different proposals, or for any manufacturer, try and do a Lotus version of it. We did one for the Nissan Bluebird, remember that? And so you may have actually been driving Nissan Bluebird today rather than Vauxhall Carltons. So I'm sure they would have been very good. But so from some of these sketches I did, and Mike went off as a salesman with these under his arm and pitched them to the GM people, and that's how it came about. Originally, it was a Senator, and I still think a Senator would have been really cool as well. I loved the big egg crate grille on the Senator at the time, and I thought that would be a very cool design. In reality, when it came down to actually doing the car appeared in its original guise as a car done in Russellheim by the Opel design team and presented at the Frankfurt show. And that was a car that Peter and our team had to put into production effectively. And that's sort of how it all started. And, so just, I can't really take the credit for doing the design of it, maybe the initial idea, but, then it was up to us to do all the aero, all the cooling, all the trim, the paint development, and all those sort of bits and pieces, which... And I did do a bonnet vents, you're right. I did the bonnet vents and the tailpipes. Yeah. And that little plate on top of the engine. That's all I did. All right.
Beautifully done too.
Thank you very much. Thank you.
Brilliant. So we've touched upon the design of it. So I'm just going to bring Simon in just to talk about a couple of things. So as a project, I'm right to understand you had essentially 5 sections you had to deal with. So probably first of all, if we were talking about the body, the chassis, and the engine, and we'll come to the other two in a little while. So let's start with body.
Okay. So good morning, everyone. So this is a really complicated program. You can imagine trying to take a car produced and its original design being done in Germany at Rüsselsheim. Mike talked about TDC. That, by the way, stands for Technical Development Centre. So that's the heart of the Opel empire, where both the Vauxhall design work and the Opel design work was all done at Rüsselsheim. So to take this car and then turn it into a production vehicle required a very complex program of being able to integrate in a pragmatic manner the changes necessary for the body, the suspension components, and the entire powertrain. My background's a powertrain man, but I think you can all recognise from the size of the engine, the complexity of it, mating that to the big ZF 6-speed transmission was no insignificant task, and then having to modify the body to fit that into it, and the drive line and some of the axle tramp issues that came with it. Then, of course, that level of performance, and when you think about performance, you've got to be able to stop the performance. So the braking performance of this car is enormous. If you're looking at something of that weight and that velocity, the energy potential is quite significant. So hence the braking system had a huge amount of development work that went into it because we had problems with the rotors cracking, heat distortion, and actually getting enough airflow through the front of the vehicle. So Julian's mentioned about the designer part of the car and that Opel had done some of those original schemes. What you see on the finished production vehicle is somewhat different because the openings on the front of the vehicle are much larger than had been originally envisaged because the amount of airflow we needed to get through the front, both for the charge cooler system, the air conditioning, the main radiator cooling system, and then, of course, the 2 vents at the bottom for the oil coolers and the brake cooling.
Brilliant. That's really interesting. Now, so Christine, you as head of purchasing, this was a very different program to the activities you were doing previously, I guess.
No, not really. Can you hear me?
Yes. Hold it right up to your mouth.
Okay, sorry. Thank you. No, in Lotus Engineering, we were doing engineering programs for major manufacturers worldwide, be it just engines or vehicles or bits and pieces. But we did small runs of projects for other people. And in that respect, this was very different. We did earlier, somebody said about the Sunbeam. We made the Lotus Sunbeams, short run, and a similar type of activity. So from my point of view, it was our bread and butter, basically, but not Opel's.
Okay, that's the interesting one. Okay, so we're a small agile company, and Opel was
just vast numbers, numbers that we couldn't even think of. And this was apparent when my early visit to Rüsselsheim with Simon and some of the others was to go through how things were going to work and the costings. And the Opel guys could not understand my piece costs for the component parts being expensive and my tooling costs being very little. Because the tooling costs for the volumes that they normally do is vast and huge and things that we wouldn't do and wouldn't in the time. because it was low volume, we could do low volume tooling for the quantity that we needed from a cost and timing point of view. And like all our programs, we were always against the clock, weren't we? So bread and butter for us, but not for them.
Wow, that's amazing. So Julian, you obviously did a lot of work with GM and the rest of the design team under Peter's leadership. So what was it like working with GM? Of course, now you've returned to GM, of course, now, haven't you?
Yeah, I now work for GM, so I now run a European design studio in the UK for General Motors. Well, to give you some idea, there's just in GM design alone, there are 2,000 people, which is probably more than all of Lotus at the time. So it's a huge department. And so here am I as a youngster trying to liaise with this what we call it the Death Star now. GM design it's a huge place, and I think our design team would have been 4 people against GM's 2,000 at the time, or something like that. And so it's very intimidating. And when Wayne Cherry used to come over, who was the European design boss at the time, it was pretty frightening for us. So he'd done the original car. Our job was to put it into production, obviously to make all the changes. Simon mentioned about the cooling. I mean, the original car had a little fog light just on the bump. Right in the vent, we had to remove that. We had to do all the aero work. It did look, to all intents and purposes, like the concept car. And so that was good. We had a review actually out there by the social centre or social club or whatever like that. What's it called?
Clubhouse.
A clubhouse. All right, a clubhouse. So we had a review out of a sunny day like this, and the first prototype was parked over there. Then Wayne Cherry comes up. He's got an immaculate suit, and obviously all the Lotus people are dressed like farmers, and so he's out there and he's looking at the car and he's going around it and checking out everything. Obviously, their attention to detail and investment in any project is huge, and he's looking around the car. And Gordon Caro, is he here today? Gordon Caro, he was in charge of the body. And when Cherry looked down at the brake vent, the big brake vent, and he said, "What the hell's this? This mesh in this metal mesh in here looks like something out of a chicken coop." And Gordon turned around and said, "No, we got this from a rabbit hutch." So, got changed an injection molded, which is one of the most expensive bits of tooling you probably had to do, Chris. So, the vents like that. So it was very exciting working with them. We did do a lot of projects after that, and we had a good relationship with them. But for me, it was sort of almost a taste of the big time working with a big studio like that. And we did several things with Wayne afterwards.
So, Julian, you were saying?
Well, no, I mean that's I think it was a great learning experience for me, and it was a great privilege to be working on a car like that. And obviously, the result was absolutely fantastic. The car looked so cool when it came out, and I'm very proud of that, and I look back at it very fondly. And some of those GM people I still work with today. There's a few of them still kicking around. So it's nice. I mean, I think that the difference is working for Lotus, working for GM. When you're at Lotus, you get to know everybody. You get to know the people in Powertrain, the people at aerodynamics, all the guys doing ride and handling. So you're really right in the sort of sharp end of the whole development process. That's what makes it so special doing a car here at Lotus.
Brilliant. Next question to Simon. Obviously, at a project management level, you had to liaise with GM all the time. We'll touch upon the engineering stuff in the next Q&A. So, what was it at a project deliverable level? What was that like?
I guess actually, as Julian has mentioned, suddenly we're a relatively small, tightly knit group of people working with a technical development centre in Rüsselsheim, which was probably 10,000 people. Absolutely a huge environment. 6,000, was it right? So pragmatically, we used to think it would be quite easy to do things. Julian mentioned about the chicken coop wire mesh. Obviously, we used to use wire mesh for the grills. Clearly, that wasn't very comfortable for a big organisation like Opel and Vauxhall. I suppose one of the biggest challenges was to be able to encourage the Opel manufacturing team to make what we saw as quite small modifications to the vehicles coming down the production line. So, of course, when they produced them, they were all produced as in the Empire Green colour. And I remember the large meeting that Chris alluded to earlier. So this was an enormous conference room, a stage at one end, absolutely full of different people from around the world. And I can remember standing up and making a plea for Opel to be able to cut the bonnet vents in the car. That didn't go down at all well. And I was pulled to one side afterwards and got a telling off. But the result of some lobbying by Mike is, in the end, those bonnet vents were cut. So they laser cut those bonnet vents, and Julian had the opportunity to design the grille that went with them. But it was almost like it's those little details that actually made the project possible or not possible. And it was a bit of a fight in many different areas to be able to convince Vauxhall Opel that they could make those changes without affecting their own production or reliability of the vehicle.
That's, again, really interesting. So, Christine, you must have had a few ups and downs with your purchasing team, having to deal with a few things.
Well, once we got through the prototype stage, because we had to obviously do all the prototype work and development for the engineers, so they got something to play with. When we went into production, it fell into our normal production delivery scheduling system once we'd sourced all the suppliers. And that was a situation which came under a hell of a problem when the decision was made by Opel to cut the programme short for the last 150 cars, because we had purchasing schedules, delivery schedules out for 5 months forward. Luckily, only 2 were firm and 3 were tentative, so we had to stop the suppliers down for 2 months. We had to take that stock because that's what the commitment was. But the upside of that was that Vauxhall needed spares, and we had 2 months worth of spare parts that were taken up because Vauxhall needed to come to us for supply, as GM at the time had this very strict policy that they wouldn't increase their supplier base. So supplier couldn't go to the suppliers that we'd set up, and there were a lot of them, and small suppliers, our local suppliers especially. So in the end, we finished up supplying Vauxhall with all of their spare parts, which got rid of the stock that I had to take in, and also gave us a bit of revenue later on.
Again, this is such interesting information, isn't it? So Mike, the car arrived on the market. Is it fair to say that it had a very polarised reception?
It's an understatement, that one. Yeah, definitely an understatement. Well, first of all, as we all know here, Bob Murray, editor of Autocar and Moto, who we thought was a friend of ours, actually, wrote this article which talked about a Vauxhall should not exceed 155 mile an hour. Which started a ball rolling with the media. There was no news going on at the time, no wars or something, so everyone picked up on it. And then it went even to the Houses of Parliament, and people started discussing it, MPs. So I was sort of hammered by all sorts of strange people, including members of Parliament. But Bob Eaton and I decided that we were not going to give in to those sort of pressures. Bearing in mind that I wanted anyway for us to launch the car at 180 mile an hour, not 176. We're Lotus, we're high performance. You guys all here, you're driving a very high performance, stunning supercar. That's what we're all about, all of us. So, when someone starts talking about cars driving along the road with the old guy waving a red flag in front of it, that's not what anybody's about. You're not about it, we're not about it. So we decided we were not going to have anything to do with that at all, Bob and I, and we declined. we were put under a lot of pressure. I remember sending letters off to MPs and offering to go down to the House of Parliament and explain to these people who ride bicycles and went around on buses what a car's all about. But anyway, eventually we launched it, as you know, at 176. But it really was a tragedy that happened, because the knock-on effect that probably no one saw at the time is that it allowed our friends, and I know Simon's very diplomatic, but it allowed our friends at Opel to, shall we say, not push the car marketing and sales wide. I signed a contract for 1,100 cars, and they cut it back to 950. The actual fact, all that negative publicity didn't do anyone any good, because it allowed a lot of marketing and sales people to actually decide they weren't going to put any money behind the marketing and sales or the PR, which, Alastair, you would know all about. So the net result of that was it didn't get on the continent in Europe, where a lot of you guys have come all this way today. Thank you very much, all of you. It didn't get the publicity and the coverage and the opportunity for people to go into the showrooms, have a ride and drive, and buy one of the cars. In fact, I wanted initially as well to sell it through our top dealers as well, Lotus dealers. Again, that was sat on by our friends at Opel. But anyway, the net result of it all was we produced it, the guys produced it, they worked round the clock, 7/24 if necessary, and they overcame an enormous number of obstacles. You'll hear Simon being extremely diplomatic, and Julian and Chris, but in actual fact, it was literally a bit of a bean feast. They were always coming up against obstacles, which, as Simon said, quite right, quite understandably, a large company producing cars like clockwork coming out of the company, they did not want to modify anything. They just wanted to shell. It's like shelling peas. And trying to interfere with that was difficult. So that did cause a lot of problems. But let me just say one thing, if I may, Alastair, before you cut me off. And that is that Colin Chapman always, I don't know whether you've all followed Colin Chapman's career, but he always wanted to produce a high performance, what you and I would call very technical, but at the same time very high performance, ultra high performance, four-seater supercar that took on BMW and Mercedes. In 1981-82, Colin wanted to do that. We started on it. It was called an M80 at the time. And that was going to be a four-seater, and that was going to use our V8 engine, a 4-litre V8 engine. Now, it didn't get off the deck because of various factors which you can read about in my book when it comes out. But nevertheless, Colin, I know that Colin, we called him the old man. The old man would have been very proud today to see all the cars here and all the contributions that the team made, the engineering team, the purchasing team, the design team, everyone, and you guys in supporting the car, in actual fact, and the company. Thank you very much for coming today. Cheers.
And that legacy has endured longer than any of the other high-performance saloons on the global market. And that's down to you guys, but it's also down to the fact that these guys and their teams delivered such a fantastic product. So please show your appreciation to Christine, Julian, Mike, and Simon. Thank you. We're now going to kick off the second Q&A, which is about engineering and development. So we're going to again be joined by, at the moment, 3 of the panel. The remaining panel member, Simon Wood, who you saw earlier, is still judging, along with Peter Stevens, your pride and joys for the concourse. So he'll join us when he can. But first of all, I'm going to welcome onto the stage Tony Shute, who was Chief Vehicle Dynamics Engineer for the Lotus Carlton Lotus Omega project. So, Tony, will you grab a seat? Secondly, I'm also going to bring onto the stage Richard Rackham. And Richard was at the time the chassis design engineer. And thirdly, we're going to bring on Graeme Turnbull, and he had two roles on the program, but primarily he's going to be here to talk about being the senior powertrain technician. So, Graeme. Lovely. So, as I said, Simon's going to join us very shortly, but the key thing now is to talk about the stuff that you really probably want to know, some of the little secrets, the backstories, the urban myths, the legends about the development of the car. And I'm going to start off actually with Tony. So, Tony, your role was Chief Vehicle Dynamics Engineer, and obviously it's a Lotus. The Lotus Carlton, Lotus Omega has to handle like a Lotus. So Tony, what sort of grabs you from that 35 years ago?
Yeah, good afternoon. My basic role was to tame the beast, to put it in a nutshell. Here was a car which had, here was a car achieving speeds that we'd not really experienced before with the standard Lotus product. And I probably, in my view, had the best job in the whole of the project, because I ended up driving the car down at Nardò, testing the car up in the Goodyear facility at Miraval in the south of France, and then in Luxembourg, testing at the Nürburgring, and finally going up to the Arctic Circle for doing winter testing. Also within this time, I was very fortunate.
Try that microphone, see if it's slightly louder.
Yeah, I was very fortunate, that's better, I think. Very fortunate to meet some of the key players on the project, like Bob Eaton from General Motors, who whenever he visited would come and drive the latest iteration of the car. And he was a very, very brave driver, and I'm not sure he had all the skills to go with it. But I figure that he was sufficiently insured and I'd be covered as well, so I just sat back and enjoyed the ride. Also at this time, we're obviously in Formula One, and it was the days when you go up to the canteen at lunchtime and there might be one or two of the Formula One drivers, and I was lucky I was having lunch. It sounds like I'm name dropping, but I'm not really. There was Johnny Herbert and Mika Häkkinen, and we were sort of chatting away at lunch. They heard about the project, and Mika said, well, could I drive one of the cars? And I said, yeah, I'll dig one out of the workshop, one of the prototypes, and we'll have a go. And this is in the days when it was the old circuit, so that the windsock was a very, very fast corner. And typical Finnish and also Formula One driver, he just goes out at maximum attack, probably 120, 130 mile into the windsock, and then he spun the car. And I said, and he was quite a young guy at this time, I said, you're never going to make it in Formula One. And he said, it's not me, it's your car's no good. And so there's nothing wrong with my car. So we had one of these silly conversations, but you could tell that the responses of a road car are so much slower than a Formula One car. But I have to admire the bravery of these guys, and I realised then that I'd never make a top-end racing driver. So, and the final thing, at Nardò, we were down there doing maximum speed runs. We tried doing this at Millbrook, because obviously it's a lot closer and a lot cheaper to get there. But the hands-off speed at Millbrook is about 100 miles an hour, so you literally take your hands off the steering wheel, 100 miles an hour, you'd just be about to hit the barrier on the outer side of the circle. Well, we were trying to do 170 miles an hour, but you'd never achieve that on a bowl, but 150, 155 miles an hour, and of course, guess what happens? The tyres started to burst, which is not great, but we never crashed a car, and finally we got some special ground down tyres from Goodyear, and it was quite interesting. If you stood on the bridge over the circuit, you could hear the noise difference between a worn tyre and a new tyre. We managed to do basically the durability at a somewhat reduced speed. But anyway, at Nardò, which is about 150 miles an hour hands off, we achieved a lap time of 171 mile an hour, and that's a lap average, which means you're probably doing about 100 and we're close to 180 on the wind behind you, and obviously when the wind's against you, you drop down. But probably the fastest time I ever did, and I never want to do again, was at the Nürburgring. There's the sort of the straight at the end is slightly down here, at the Tiergarten. And I was pulling an indicated, so I don't know how valid it was, 300 kilometers an hour. And it kinked slightly, I can't remember if it's right or left, halfway down. And there was a Fiat 500, which was probably doing a very high speed for a Fiat 500. And I was approaching at some ridiculous speed. And you have to choose, do you lift off, potentially put some instability on the car, or just floor it? So I just floored it. But I wouldn't want to do that again, I really wouldn't. But I think the great thing about the car was the aerodynamics as the base car was very, very good. And the extra long wheelbase as well made the transient manoeuvres going in and out of understeer, oversteer were quite gentle. So the car became relatively easy to start tuning. And the other thing was it's got self-leveling suspension at the back. So one, tyre durability wasn't a massive issue. One thing I did do was Goodyear had a 7-rib rear tyre, and we hand-carved a 5-rib one, and it immediately took half a second off the 60 time and gave the car a lot more stability, which was interesting. And I think the final bit before I hand over, I went up to the Arctic Circle with the car to do winter test. I thought this is going to be exciting, but actually it wasn't. The car was really good. And we had basically a Goodyear winter tyre and a Michelin winter tyre. Michelin joined us to help with the development. And there's a hill at Eierplog where you drive up and you almost see how far you can go up before you lose traction and go no further. The Goodyear tyres, it just went from the car park to the top. So we thought we'll try the Michelin tyres because they were very keen for us to actually release those onto the car. We couldn't get out the car park. so they were quite embarrassed, and I was quite pleased because you didn't have to start doing all the detailed sort of development work on it. But anyway, most enjoyable project. I hope you're enjoying your cars, and I wish I owned one, but I don't.
That's really interesting. So we'll move from the vehicle dynamics to what a lot of people regard as being the heart of this car, and that is the powertrain. And Graeme Turnbull, you had two roles in the program. So we'll touch upon the first one, where you did, as a powertrain engineer and technician, you did prototype and development. Where was that, and how did it come about?
Well, I suppose in my time at Lotus, I've been lucky enough to work on some pretty high performance engines, as most of the engines that we developed in those days were high performance engines before we got into the family stuff. So we were lucky. David Hanna over there and Andrew Arden behind him. David was the fellow technician. We built the first prototype engine, and Andrew Arden was our development engineer. So the standard engine that we took was obviously the engine was going to have piston cooling jets, which the block was not designed for. So the first thing was we had to pipe up and put in place piston cooling jets, which were then driven by an external oil pump, because we weren't sure whether the standard pump would provide enough oil to do that. So that was, we got the engine going and got it on the dyno, and I'd have to say it was one of the most difficult engines that I had experience of to drive on the dyno. If you can think that when we first put it on, we've got no calibration. The calibration boys can give you something basic because they know how much air is going in and so how much fuel you need to put in. But apart from that, that might take you sort of in 2,000 steps, but you've got to drive it below that and do the calibration. So taking the engine up to the next speed, adjusting the spark, adjusting the fuel, adjusting both turbos to get everything balanced out. That would then get stabilised, go up to the next one, and when you got going, you kind of got into it, and it wasn't too bad, but then suddenly you're at your 7,000 RPM, 400 brake horsepower, and you're thinking, well, I've got to drive it all the way back down again now. And that used to take a long, long time to do a power curve, give some indication of the durability of the engine at that time, really. And we did tend to run a lot of the work at 400 brake horsepower, giving us well, I suppose, a pretty solid durability test. And eventually the thing was certified at something like 376 or whatever it was. But yeah, it was an interesting engine, very interesting in project. So yeah, it was good. I don't know what more to say about that really, apart from there's an awful lot of work that then goes on. You get the calibration, you then get an in-vehicle calibration, that goes back on the dyno, and then you start the durability work, which in GM's days was very, very comprehensive. We had to comply to all of GM's durability criteria, and some of the tests were quite strange, but I think at the end, the last test that we do is called a green engine test, and that's supposed to simulate somebody going into, generally Germany, but going into their dealer, and they can start the car up, they can drive it out, and they can drive around for 15 or 20 minutes to the nearest Autobahn entry, and then they can drive it flat out, whatever. And that was a green engine hours test that we did, and that was always the one where it was an edge of the seat job. Just well, two things really, hoping to goodness sake that the dyno didn't pack up working, and we got to the end, but yeah, we generally did.
Again, 400 horsepower. Did you guys know that? So Richard, your background, you are a chassis design engineer, and you've got 376 horsepower, potentially 400. Your job was to try and get that under control, to get that put onto the road.
Well, it was kind of how to stop the car. You know, getting the power down was obviously about the dynamics, about the tyres, about the changes to the rear geometry. But there was an issue, obviously. We knew from the beginning that making the car stop as quickly as it went was going to be a challenge. Now, I was at the time chassis engineer, and I'd worked on every racing Esprit, from the first race in Esprit right through to the 93 Le Mans car. And we'd worked with AP Racing throughout that time. AP Racing are, it's gone a bit funny, AP Racing, is that better? Yeah. AP Racing, we had a really good relationship with Richard Joyce, who was then sort of a regular engineer. He's now the technical director at AP Racing. And so we approached him, and he said, well, how much space have you got for this? And so I told him how much power the car was going to have. He said, you're going to need a big brake. And so we sent him the wheel profile over, and he came up with some disc brakes with opposing piston calipers straight out of the racing box, really. And they were on the development cars. It's a two-piece disc, sort of. You know, so you've got a bell and then an aluminium bell with a cast iron rotor bolted to it. And they went into the early development cars, and they performed very well. They obviously, at that time, AP Racing had never supplied a production road car caliper or brake system. And so we had to work with them to ensure that there was corrosion problems because on a race car, you know, it's kept clean all the time. And
driving me mad, this thing. I'm going to speak a bit louder in case. Is that better?
Yeah.
Okay. So we had to work with AP to get rid of the potential corrosion problems, and also the rattle, because the rattling from the brake system and squeal from the pads. All of those things are okay in a race car, but none of them are okay in a Lotus Carlton. So this was a learning curve for us and AP Racing. So we went through all of those things, and they kind of taught AP Racing into road cars. And subsequently, of course, when I was working on the Lotus Elise, the obvious choice was for AP Racing calipers, because we had a good relationship and we knew that they actually had quite a good bling to them. They looked pretty good. And with the Elise, I noticed this about the Elise, but what was there had to look good. Anyway, come back to the brakes. So there was a lot of brake testing going on, and frankly, I think we changed the rotor thickness by a couple of millimeters, but the diameter was fairly stable from the get-go. It was painless, really, but of course you can't afford a two-piece disc when we're in production, so I had to go to a single-piece disc, a cast iron disc. So AP Racing, again, they're going into a world that they're not really that familiar with, a single-piece disc. So I drew up a disc, and we had it made and put it on the car, and it was the retardation, because it was drilled in a similar way. The retardation was good, but there's a strange thing that happens with a two-piece disc. When it gets hot, it grows radially, it gets bigger, and the little bolts that bolt the thing to the hub, they take up that growth. There's just a few thousandths of an inch movement in that bolted joint, all a ring of, say, 20 bolts or 12 bolts. And so the disc keeps in plane. When you do a single-piece disc, that growth isn't always in plane of the disc, and it can kick over. It's called coning. And so we did find a little bit of coning in the single-piece disc, but it made the pedal a little bit long. If the disc had got really hot when you're braking, and it cones over a little bit, of course you're on the brakes, so the pads are coning over with the disc, so you don't know. Because when you go for the pedal the next time, when the disc is cooled down, it's pushed one side of the pad has gone back in the caliper, and it's left the other side, other pad, in one side of the cap. So there's a big gap to close up when you come to the next corner. But it wasn't excessive, it was noticeable, and it was seen as an extreme case. So far, so good. And then came an event when I think they were GM executives, were visiting for a progress status, and they got on into this development car with a guy called Dave Minter, who was one of the ride and handling engineers, and he did a warm-up lap as you would normally, and then he did a very fast lap, and he's got a guy beside him and two guys in the back, and they're all having a lovely time. And he went out of very fast lap, ran that end of the track down to the break the king, and then flat out right down to the hairpin that you go through later. And when he got to the hairpin, he went for the pedal, and the pedal was very long. And the pedal was very long because there was so much weight in the car that because of the development he'd done, at the most 2 occupants in, now it had an extra couple of 100 kilos. And so there'd been a lot more disc coning. So he went for the pedal, and the pedal wasn't there, and he went straight through the fence at the end of the straight through. And he kept the car upright, but it was a bit of a shock, and I've been in contact with Dave. He'd rather forget the event, so I said I'd talk to him about it. But it was not, I said it's a design thing. We hadn't proven out this. So then we had to quickly come up with what we call a swan neck disc. So rather than the disc being in plane with a mountain face, it goes the mountain face onto the hub, and then it curls around and goes back again. The idea being the thing kind of goes this way and that way as it gets hot. And it worked. But we didn't know there was still coning. I think, Tony, we were trying to measure the coning. And Tony was, I'll go and put some heat in the disc, and you wait here in the workshop, and you can quickly come out and measure. I will have the wheel off and we'll measure the coning in the disc. All right, well, yeah, that's going to cool down a bit. No, I'll get it hot. So Tony went and we had all the clearance, the track exit had been opened, hadn't it? And with all the doors to the workshop were open. And the car came in onto the ramp. I've never seen a car go onto the ramp as quick in my life. Tony jumped out. The technicians there, trying to get the wheel, and suddenly the thing caught fire. By this time, Tony was round this side. He said, "Is that hot enough?" So we did get there, and you know the brakes are good. And it's but there were things that happened that shouldn't have happened, which I can tell now after all this time. The Dynamics guys, the ride and handling guys, particularly Murray White, who's now technical director of Multimatic, and I'm sure he won't mind me saying, him and I think Graeme Sutherland was another one who's now working out in America. They enjoyed putting laps on the car around the track, developing the thing. They enjoyed it immensely, and they particularly enjoyed having a lot of power on the rear axle. And they had this little thing going where they want to see how quickly they could make the rear tyres illegal. So when no one was looking, they'd go out and do laps with the tyres lit up as much as possible. And Murray White won 2 laps. From a brand new set of tyres to being on the wearing the things. So you can have a lot of fun if you want. Also, what we had an idea that it'd be great to get a photograph of the car disappearing in a cloud of smoke from its own donut. So Murray was doing some calibration one day, and we went out to Tiverton Airfield, and I had my camera, and he just tried to make this cloud of smoke. I've still got the photographs. Unfortunately, there was a slight wind. And it didn't disappear, but that should never have happened, but I'm sure that helped with the tyre development. So when you go on the track, as you come down round the kink and you're going down to the hairpin, you'll notice there's a chicane, and that chicane went in as a result of this break-in. They went in for safety reasons. So you'll be okay.
So, Graeme, coming back to you, the production of the engine was also, you were part of that team, and you had to build 950 of them to absolute spec within a very short period of time. So can you tell us a little bit more about that?
Since Richard's on the stories, before I talk about that, I'd like to say a little story about when the cars went down to Nardò, and David Hanna there was the technician that was sent off to support the engines. There was 2 cars that went, and in those days we had all the engine management stuff, and the calibration was longhand. There were reams and reams of paper, and fed it into the engine management system, and we only had 1 copy of this. So it was heading down there, and I think Simon was driving one car, Dave, was he? No? Okay. Kevin, right. And so Dave has got the pictures for anybody who wants to look later. So one of the other car needed the Bible, as it was called, to do the engine management. So there's the Italian Autostrada. There's 2 Omegas doing 100 miles an hour, side by side, with David there passing over the paperwork to the other car, which nearly blew away. So he was warned what would happen if it did. So yeah, we used to have a bit of fun as well. In terms of the production of the engine, yes, the line was set up over in Factory 3 to build the car, and we had to build the engine on some kind of production basis. So we set up a kind of mini production line where we had sub-assemblies, the manifolds, turbos, was all built on a sub-assembly. The block and pistons and whatever were all built separately. The cylinder head was built up, and then all of those parts came together where the cam timing was done and the engine was completed. We then went to a hot test and a power curve. So the engine went on a quick fix dyno, which did several hours of braking, and then it did a very quick power curve, and as long as it reached the sign-off, it came off and was sent over to the line. As I said before, at that time we were heavily into GM quality systems and all that sort of thing, and we had some consultants on site, and we were probably sending an engine, or could send an engine over there about every 14 or 15 hours, something like that. And these guys, time and motion type people, looked at it, told us, in their view, 8.5 hours is what it would take. And surprisingly, I just didn't see how we could do that, but surprisingly, by the time we'd finished, we were very, very easily doing that. The engine would go on the dyno, another one would be rigged to go on the dyno. When that one came off, that one would go on, and we were running it 24 hours. We weren't building the engines 24 hours, but we were dynoing them every 24 hours. So yeah, we worked through, and as any problems, didn't really have any build problems, but yeah, we mastered it in the end. And so the other point was that at that time, we could have been busier, if I'm honest, within Lotus Engineering. We'd finished some big projects and some projects hadn't started. So we were able to transfer the technicians onto either the engine build line or in the Factory 3 line. So yeah, all your vehicles were built by pretty good technicians. In actual fact, we had to try and re-educate them a bit. And if you want to put that piston on that conrod, you don't actually have to put your finger in the hole and make sure it's all okay. That's all done. You just slap it together and job done. But once we got past that stage, we were okay. Another group of people that we'd got was the trainees, and they were transferred over there. And we've got one famous class, the class of 92, and they were engineering apprentices that started in 88, finished their time in 92. So they were transferred over to there. So now this won't make a blind bit of difference to the value of your car, but we had Gav Kershaw's here. Oh, there he is, Gav Kershaw. So he was one of those, and is still at Lotus, and I probably can't pronounce his title now, but pretty influential person in the motor industry. Matthew Becker, who did all his ride and handling work here and then went to Aston Martin and is now some glass office person at JLR. Again, I don't know his title. James Key was another one. Went off and he went into Formula One, and he was the Chief Technical Officer at Force India, several other places, McLaren, and he's now at Sauber, ready for the Audi takeover. So, as I say, some pretty influential people that probably bolted a bit on your car, and they eventually did very well. So we're proud of that aspect of it as well. Thank you.
So that gives you a bit of a taster to some of the vehicle engineering goings on behind the scenes. I hope some of those stories are those which you'd maybe heard as an urban myth, a legend, or maybe you hadn't even heard them at all. So please show your appreciation to Tony. Oh, yes.
Sorry, I've just been on holiday and laying on the beach in Portugal. Got talking to the guy on the bed next to me, who was equally as fed up as I was. So, and suddenly he knew all about Lotus, and I was quite surprised. He knew all about engineering, blah, blah, blah. And it seems that he worked in IT, and he worked for Hewlett Packard back in the day, and he spent quite a bit of time in Norwich when Aviva changed all their system, and he worked there. But he actually, I can't remember his name was Steve, but I can't remember his name. He actually owned 2 Omegas back in the day. He bought a new one, and then after a few years that went, he bought a second-hand one, which he kept for quite a few years. And he said, I've got to ask you a question. So, is it right that you buried at Hethel 150 blocks in the ground that you didn't... where did that come from? He said, somebody told me, but who knows?
So do we need to start exhuming some engines? Now, I spy over there Simon Wood, who, by the looks of it, has probably finished his judging. So I'm just going to bring Simon. Would you like to join us back up again for just to talk a little bit more? Simon was project director, and he's talked about the body engineering, some of the chassis engineering earlier in the day, and but of course, a lot of the significant part of the program was both development and manufacturing. So Simon, what challenges did you have as part of the manufacturing program, putting a car into production, which at volumes which were pretty high for Lotus, but minuscule for GM?
So sorry to be late coming down, because we were just finishing the judging, so I don't know what you've been speaking about for the rest of the time. Thank you. No, nothing changes there. So bringing the car in, I guess the biggest attribute was actually trying to get the logistics working, because once the development and the design process had been finished and the tooling had been produced and the components started coming in, then we had to obviously work closely with Opel at Rüsselsheim in terms of getting the flow of the vehicles into factories ready to build them. So they were delivered on transporters. I think there was 11 vehicles per time, and they were on a circular route. So the car would come fully sprayed and fully built as a vehicle from Rüsselsheim. And a few people asked today, where were they painted? And I can say that all the cars were painted in the Rüsselsheim paint shop. Everything is steel on the car, so they all came as the imperial green colour. They had slave bumpers, front and rear, a slave engine and transmission, slave wheels. So we stripped all that off, and it went back effectively on the transporter back to Rüsselsheim to be built on the second shipment of cars that came in. One of the problems starting the programme was that it was at the interchange of the model year from model year 90 to model year 91 for Omega, for Opel. So we had to do some conversions of some of the early cars to make sure they were the same model year throughout the build period of the vehicle. Once they came into the factory, they went to a full strip down, then the cutting and shutting the body to fit into the transmission tunnel and for the wheels. That was all done with plasma cutting. The new components were fitted in. It went through a corrosion protection process. The engine was built, I guess you've spoken about the engine build at some point. So the engine was built off the side of the line, shipped over into Factory 3, installed into the vehicle. The body panels were produced by Dove in Dereham and painted locally in Dereham to the same colour, shipped in and then fitted onto the car. The modifications to the rear suspension were carried out, if I remember correctly, in the fab shop. Yeah. And then the complete kit was built up, went for a test, and then each car was filled with enough fuel for about 20 miles to run it into the track to make sure it was okay. Then it went back on the transporters and was taken out to either a Vauxhall or Opel dealership.
microphone, so it's going to be me shouting.
Quiet, please.
Yeah, it's going to be me shouting because we haven't got a microphone. There's a couple of points. I mean, I was involved in the aerodynamic and the styling, visual appearance of them. Simon was really in charge of the project, and his battles were with the engineering people in Germany, and mine were with the design people in Germany. I think by ignoring those battles and actually getting on and doing a really good job, we ended up with a fine car, which was particularly nice. Some things which fascinated me when I looked at all these are 35-year-old cars, and the interiors of all of them have really weathered startlingly well for a 35-year-old car, whether they're 40,000 miles or 200,000 miles. You know, it's amazing. The other thing is that for cars at a Concours, these are driven so many more miles than I've ever seen at Concours, where you get 3,000 and 4,000 mile cars. You know, the span of mileage that these have done is extraordinary, and it suggests to me that the people still like them and they're still fun to drive, which has got to be great. The other nice thing is that we've had people from a lot of different countries here who've brought their cars, you know, and they all have fine stories to tell, so all of that was nice. And of course, all of that confronted with nearly 60 cars made it an impossible judging situation. So
all the same, 60 cars.
yeah, and I mean, in effect, all bloody good, you know. That is, which makes it. But we didn't cheat and just toss a coin. We did actually have a list, and we put various categories.
There's some maths behind it, wasn't there?
Well, there was maths, and we had to.
I realised you struggle with the maths.
We had to do adding up of numbers at the end, and we didn't ignore them because they were actually quite valuable. Two classes, one is for Omegas and one is for Carltons. If we start with the Omega ones, now what we decided to do is not, if we'd done first, second and third in order of how perfect they were, you know, it would have been tiny granular differences. So the first prize is definitely for the condition in which the car was presented here. You know, in other words, the best Omega. The second prize actually goes to what we call well used and well driven, but still nicely presented. And the third award goes to the one with the most high mileage, which is quite extraordinary. So we're starting with Omega, and the first for what we might call the condition, we've got the number plates here, EK 12452. Which is you, absolutely, and it's Sven, and
Congratulations.
Thank you very much.
and
Well done.
that should say Omega on it.
Yeah, it does.
Good. So far the system has worked really well. And you brought the car all the way from
Denmark.
Denmark. Okay, well that's good. Yeah. On the hook of Holland to Harwich.
We're using the tunnel, and then we are
All right.
driving through Belgium,
Okay.
France, Belgium, and Holland, and some autobahn.
Yeah. I'm going to ask you, but you're not going to Roma weekend after next, to the beach races?
No.
Otherwise, not with yours, but I'm racing there with the old one, yeah.
Maybe I can see what I have in mind.
Yeah. Anyway, this is really nice.
Thank you very much.
Now, the second place one is number plate ELC 38. Hey, right.
Thank you very much.
This is good. And it's, here we are. We're all going to shake hands with you as well. Here you go.
Thank you very much.
He's like Donald Trump. He
From
goes on
Poland.
shaking until it's
Okay.
had tea. There we go. No, this is good. And you brought your car from Poland?
Yes, we bring car from Poland.
Yeah, which is just only car in Poland?
No, it's not only. We have 8 of them. And,
Really?
Really, and we have...
That's greedy, isn't it?
One. One with a really low number, it's 16.
Yeah.
It's only 20,000 kilometers, so it's quite nice. There is the second one with low mileage. And there are a lot of cars with different history, also with time history, but
Which
I'm
is
not
great.
going to explain it.
No need, because you want to get home, yes. Okay. And the third prize, which is the mileage, goes to 55 DRNB, which I think is a Dutch registration. Omega here.
You should have been a bigger one.
Well, couldn't afford it.
I drove all the miles of it. It got a bit mean.
Hey, I got a prize.
You got a prize, that's right. And it's
Thank you.
Yep.
Rob from the Netherlands.
from the Netherlands. I'm going to tell you a really bad story. The only guys from the Netherlands that I saw driving one of your cars was they were upside down at the end of the test track, and they were three Dutch journalists. Yeah.
I think I heard one of the staff in the factory tell that. He didn't say they were Dutch. I don't think he knew, but
but the car
was local here, though.
the car looked after them very well.
I heard they drove it out. So
It's not a test we need to reproduce, but yes.
I only temporarily hold the car for next generations, maybe.
Okay. Well, that's good.
And I got a driver with me. He'll be careful today on the track.
Good. Well, thanks very much. It's good. Okay, we now come to Carltons, and first, because it was startlingly fine, is J366. J366. Here he comes, here he comes.
Wow.
Hey!
Thank you. You deserve that. Beautiful. Absolutely beautiful. Thank you. Turn around and give us a photograph. Yeah. Congratulations. Thank you. Absolutely beautiful. Thank you.
Yeah, it was very, very fine, very fine. Okay. For what we might call well used and clearly driven is ELC 38.
No, that's over.
Is it? I'm sorry, it's not. It's 890 LC. That's this one, 890 LC. Here he is, it's you, yeah.
Thank you. Turn around here.
Yeah, indeed. Yeah, really well. Thanks yourself.
Congratulations again.
Thank you very much. Yeah,
Should have moved them apart more.
all that effort goes to give you this.
I'll keep an eye on you.
Yeah, it was good. It was well done, you know. Yeah.
Labour of love, as they call it.
Yes.
Like everyone.
But properly used as well.
Oh, for sure.
Which
yeah,
has got to be good.
You've got to use them.
Yeah.
Otherwise you might as well leave it in your living room.
You never lose them. Yeah.
Okay. And the third place, that goes to K663, and I would just tell you that the mileage is 203,000 miles.
Fantastic. Congratulations.
I didn't do all of them myself.
And it was actually in fantastic good condition as well, the mileage. It was good.
Take you to clock that on the old...
On the electric drill, yeah.
By the first owner.
I think you should check the MOTs on that one, Mike.
Yeah.
Well done.
So it's good, yeah. So I think all we want to do is thank everybody who brought their car here, and often at Concours, when it's not true, people say, that was just a whisker of difference between them. But this really was true, you know. There wasn't a bad car here, you know, and particularly I was really delighted that there wasn't a bad interior either, you know.
Yeah, that was remarkable, wasn't it? Considering
It was.
That's 35 years of use.
Yeah.
And
The leather work was remarkable.
this was a company which each interior on the production cars was effectively unique.
Yep.
Here we were going into a production run and still you know, the quality and the repeatability was super impressive, actually.
Super, fantastic.
I shall phone up
So
Andy
good
Harrison and
quality.
tell him. Well, it was.
High quality stuff.
Quality, yes.
They are, Alistair.
Brilliant.